everybody, this is Mrs. Snook with section 6.2, which is properties of parallelograms. And our objective today is to use relationships in parallelograms between their sides, their angles, and their diagonals. First thing is the properties of parallelograms. We're going to start with the definition of a parallelogram. And what that is a four-sided figure. And the opposite sides are parallel to each other. And I would write this in shorthand. Parallelogram implies opposite sides parallel. So if I was to name this parallelogram AMHS, I could then say that line segment AM is parallel to line segment HS. Next one is the opposite sides in a parallelogram. So not only are they parallel to each other, but they're actually congruent. So if I have my same parallelogram, AMHS, line segment AM is congruent to line segment HS, and line segment MH is congruent to line segment AS, because parallelogram implies opposite sides congruent. Next up is opposite angles. So again, we have AMHS. And the opposite angles in the parallelogram are congruent to each other. So angle M is going to be congruent to angle S. And angle A is going to be congruent to angle H. Next one up is consecutive angles. And what that says is that the consecutive angles in a parallelogram are supplemental. If you think back to chapter 3, when we had two parallel lines cut by a transversal, the same side interiors were supplemental. So in our parallelogram, the consecutive angles, those are same side interiors. So they're going to be supplementary to each other. So then angle A plus angle M equals 180. Angle M plus angle H equals 180. Angle A plus angle S equals 180. And then angle H plus angle S equals 180. And in shorthand, I would say parallelogram implies consecutive angles are supplementary. Diagonals. So in a parallelogram, I can put in one diagonal. Actually, I can put in two. And what I'm going to do is I'm going to pick a corner, and I'm going to go to the opposite side. So skip the angle that's right next to it. So skip the consecutive one. I'm going to take my other corner, go across, skipping the consecutive one. So then what I have here is the diagonals. And what these diagonals do is they bisect each other. So parallelogram implies bisecting diagonals. So what this means is if I put a point here in the middle, I'm just going to call that point P, I can then say AP and PH are congruent. I can also say that MP is congruent to PS. And those are the properties of parallelograms that we're going to use to solve problems. So let's do some math here. So, Take out a pen. So what I'm going to do is I'm going to look at parallelogram ABCD, and because it's a parallelogram, I know right away that line segment BC is going to be congruent to line segment AD. And this is because parallelogram implies opposite sides are congruent. So for that reason, I can state those two are congruent to each other, which means 5x plus 19 equals 7x. And then I can easily solve for x. Just subtract the 5x from both sides. So I get 19 equals 2x, and then x equals 19 over 2. So that's x. Now let's get y. Now for y, I'm looking at the angles. And I know that consecutive angles in a parallelogram are supplementary. So what I'm going to do is I'm going to write the equation 6y plus 5 plus 10y minus 1 equals 180. And this is because parallelogram implies consecutive angles are supplementary. So that's my reason for writing that equation. And believe it or not, that equation, that's the geometry. And so now all we're going to do is solve that equation using our algebra skills. So I have 6y plus 10y is 16y plus 5 minus 1 is 4 equals 180. So 16y is 176. And then divide both sides by 16 and I get y equals 11. So that one's done. Now we're going to look at our other parallelogram. This one we have information about the diagonals. Diagonals bisect each other. So right away, I'm going to mark line segment FJ congruent with line segment JH. That allows me to write this equation. 4z minus 9 equals 2z. For the same reason, I'm going to mark line segment EJ. I'm going to mark that congruent with line segment JG. And I can write the equation that 3w equals w plus 8. And the reason for both of those equations is parallelogram implies bisecting diagonals. Okay, so now I've done the geometry, I've written my equations. All I have to do now is solve. So looking at the first one, the equation for z, if I subtract 2z from both sides, I get 2z minus 9 equals 0. Then add the 9 to both sides. So 2z equals 9. Z ends up being 9 over 2. That one's done. Now let's solve for w. I'm going to subtract w from both sides. So I get 2w equals 8, and then divide by 2, w equals 4. All right, everybody. That's it for today's video on section 6.2. Thank you for watching and have a